This episode is sponsored by Micro Focus and the LoadRunner Solutions family. That includes LoadRunner Professional, Enterprise, Cloud, and Developer. You know, performance matters. Did you know that LoadRunner Solutions have the largest community of practitioners in the world? Join that community at community.microfocus.com, scan the QR code, and check out the LoadRunner family page on performance engineering, as well as their YouTube playlist that we've got links for in the show notes on smcjournal.com as well as YouTube. Hello, everybody, and welcome to the SMC Journal podcast. This is the show that's all about software engineering and IT today, and that has to do with performance, observability, security, and anything that has to do with making applications faster, better, and more efficient. I'm Scott Moore, your host. Thank you so much for being with me today. As you can tell from our background here, we're not in our main studio. We're actually still on the road doing shows remotely, but we're still able to bring you wonderful content wherever we are. So today, I want to focus on the term benchmarking. Now that can mean something different depending on if you're talking to a developer, a performance engineer, software engineer, or other. But today we're going to talk about it in the terms of benchmarking developer code. Now, of course, there's a lot of solutions out there that are sort of one-offs or what I might call utility solutions per language that you might be developing in. But has anybody ever thought about trying to solve the bigger puzzle piece of being able to do that in one tool, no matter what language that you're using, and actually make that benchmarking a continuous activity by putting it into a CI pipeline? Well, I'm glad you asked that question. The same as I have. Everett Pompeii, my guest today, has tried to do just that. So we're going to jump right into this topic and bring on Everett. Why don't we do that now? Everett, welcome to the SMC Journal podcast today. It's good to have you on the show. Why don't you introduce yourself and give us a little bit of information about you and this product that you've got called Bencher.
I'm Everett Pompeii. I'm a software engineer and the founder and maintainer of an open source tool called Bencher. Bencher is an open source tool to help developers catch performance regressions in CI. I'm a software systems engineer, so kind of more systems level programming historically. And so I was working on kind of lower level network kind of software, and performance there is super critical. And I was having to, benchmark a prior version of the software against my newer version to make sure that there was no performance regressions. And I had to go and use a spreadsheet. And anytime I touch a spreadsheet, I think there's got to be a better way, right? And so I started to do some research and look into what were the alternatives other than a spreadsheet. And there are a lot of great tools out there, but they tended to be very specific just for a language or for a benchmarking framework. And so I was wanting something due to the nature of the tool that I was working on, which I needed to work across multiple languages. I was mainly coding in Rust, but it also needed to work in Python and Java, Node, and .NET, amongst other things. And so looking at that and looking at what was out there, I decided, I had to kind of build it myself. And I just wanted it to work out of the box and not have to string a bunch of things together.
So I understand Bencher is a continuous benchmarking tool, but when we talk about benchmarking, what exactly do you mean by that? And why is it important to do this within a continuous pipeline?
So by continuous benchmarking, kind of the idea is that for the same reasons that you run your unit tests and integration tests in CI, that a team should run their performance tests in CI. Right now, benchmarks tend to be kind of one-off, and maybe towards a release you'll run them and things like that. And it really looks a lot like what we used to do for feature testing way back in the day before CI caught on. And so I think continuous benchmarking is for performance-intensive applications where they really actually care about performance regressions. It's that next step in evolution there. And right now, a lot of this is done in production. It's a billion-dollar industry. Observability application monitoring, pick your, buzzword that you prefer to use. And, you go and you look at it when it's on fire and it's affecting your customers. And that's usually when it gets detected, which is just way too late. And so shifting that left, as far left as possible within the development cycle, I think is great. And, the goal of Bencher is not to replace any of the harnesses that users might already use. We work with your existing tools. And so if you have your benchmark harness of choice, that's going to be best for testing things locally and working with that. But in the same way that we don't expect developers to run all their unit tests on every code change themselves, like that's what CI is for. For continuous benchmarking, again, that's what the continuous benchmarking is for. So you don't have to do that every single time. And so it gets caught in CI.
So I checked out your website and it says that Bencher will work across many different languages. So how did you make it a language agnostic product?
So yeah, since Bencher is language agnostic, there are a couple of ways that you can get your metrics loaded into Bencher. The first one is using the CLI that we provide, which makes it super easy, especially if you're using one of the supported harnesses. You just give us the command you want to run, we take the output, we parse it, and then Bencher stores the results. You can also, if you have a custom sort of benchmark harness, if you can output the data in the expected format, then you can still use the CLI, and we would just ingest that JSON and save it in the server. And then the third option is if you kind of have something that's really bespoke and you want to kind of handle it all yourself, then you can do all of that and just take that JSON and then send it to the REST API on the Bencher server, and you'd be good to go.
So where does the output from Bencher go, and how is it viewed or visualized so we can make sense of the data that's produced?
Yeah, so we mentioned that JSON format would get sent to the server, and like what happens with it there, right? So on the server, when the results are sent to it, it parses the benchmark harness output, extracts the data that's important, and then stores that in the server. And that is super useful because it allows you to take that historical data and use it if you set statistical thresholds. And those thresholds are used to generate alerts in case you have a performance regression. And those alerts can then fail your CI jobs if they get created. So really the back-end system and storage there and analysis is the key part that the Bencher backend is doing. And it's not just all API calls. There is a UI where you can go and interact with it. We'll kind of take a look at a demo here in a minute of that. And it'll just give you a nice chart, and graphs, and all of those things of your data. And it's improving all the time. So if there's any features that you'd like to see there, also please open a PR, or we're on Discord. You're welcome to hop on, and suggestions are more than welcome.
So I understand you have a quick demo for us to actually see what Bencher looks like. Can we actually bring up that demo now?
So yeah, let's hop in and go do the demo. So just before we dive into the Bencher itself, let's just take a look here at GitHub, which the GitHub project page, which is really, kind of the home page here for us. And this is where you're going to be able to pull Docker images and things like that for the project. And there's a bunch of information here listed, kind of going over same sort of things I've been talking about here today about what continuous benchmarking is. Great link here to join that Discord again. And then links to all the documentation, the supported harnesses here, C#, C++, Go, Java, JavaScript, Python, Ruby, Rust, and anything else that you all might want to add. There's also the ability to share your benchmarks. So this is a pretty neat feature, I think. It automatically generates these perf charts of the performance of your software over time. And we can look here in a minute how to generate those. But the cool thing is that these can be embedded inside of your README, as you see here. GitHub doesn't allow dynamic content. So these are just static images as far as GitHub is concerned, but they're made on the fly as soon as the request is received on the Bencher server. So these are pretty cool. And then there's also GitHub Action. So if you want to use Bencher in your GitHub project, make it really simple to integrate it in there. And then if you'd like to contribute, also try and make that super simple. You just click this button here and it's going to open up a local dev container for you to have everything spun up, and it's going to spin up a server and the UI and see the database and everything. And so you'd be good to go. You can also do it inside of a GitHub code space. So that is pretty nifty if you want to check it out and maybe contribute back to the project. So let's take a look at the website. This is just kind of our landing page here to catch performance regressions in CI. And you can just go ahead and check out kind of a lot of the, the text here is just explaining things that I've previously gone over. But let's go ahead and log in. So you go ahead and log into your account. And then once you're in, then this is just kind of an example of kind of having some data in here. This is a perf chart. We have selected latency as our metric kind. There's quite a few. Those are customizable. So if you have a custom metric that you want to track, then you can create your own kind of metrics. Then there are branches. So, the Git branches that you're using. And these can also automatically be created in CI and clone the data from another branch if you're working on a PR or an MR. And then test beds are just the test bed that you're working in, the computer anyway. If you have like a large Ubuntu instance and then maybe small Windows instance, right? Like those are very different things. And so you want to be able to distinguish those. And so that's the dimension there for the test bed. And then there's your benchmarks. And you can select multiple benchmarks at a time to compare them if you like, and kind of work through it that way. And so the other really nifty thing here as we kind of look at our data is if we wanted to add a threshold, again, those statistical thresholds, this is how we would set that up by adding a threshold. And so we could select the metric kind and the branch. We can do a z-score or a student's t-test. And we can set up a left side or right side boundary on that. And so the left side would be things where, lower, like higher is better and low is bad. And the right side boundary would be the things where like lower is better and high is bad, like latency. And you could have a minimum and maximum sample size, and then also a window in seconds for kind of how long you want that to be. So that is how you would set up a threshold. And once that threshold is triggered, then you can come over and look at your alerts. So this is an example of an alert that has been generated. It was a right side boundary of 0.6, which means like beyond 60% kind of confidence interval there. And our outlier was pretty far out there at 0.92. With these kind of maximum is 1. So that's pretty far out percentage-wise. Cool. And you can have multiple projects. So right now we're just looking at a project called The Computer, but you can have multiple projects, and you can also have multiple members. So right now Muriel Bag we're looking at her account, and and you can also set up API tokens to make it easier. So Muriel doesn't have to give her credentials over for the CI workflow. She can set up an API token here. That's Bencher.
Thanks for doing that demo for us. I could see how this product Bencher could be extremely useful for helping developers keep performance and optimization of their code in the forefront. Like while they're developing the code, they'll actually be thinking about as they're developing this feature, this functionality, is it getting better, is it getting worse, and getting that immediate response back. So why hasn't anybody come up with the universal way to benchmark code up until now?
So yeah, why am I the first one to build this? Well, I'm not. There's actually been a lot of folks who have reinvented this wheel over time. But as I mentioned, they tend to be very bespoke wheels, and they are wheels just meant for kind of, their one cart, if you will. And the goal here with Bencher is to support all of those benchmark harnesses and to be a much more general solution that has all the bells and whistles built in that one would need. And so that's kind of really the big thing. There's nothing that just works out of the box. There's a lot of great blog posts and articles about either people, cobbling something like this together themselves with tools that already exist, or building it themselves just for their project and having a bespoke solution. A lot of FANG companies have done blog posts talking about, hey, we built this really cool benchmark tracking tool. We might open source it, and none of them ever have. So, there's just nothing that's really out there for users like myself to use that checks all of those boxes.
Last question. Isn't doing this benchmarking sort of noisy? Do you have noisy neighbors or there's noise on the machine? Wouldn't you need an isolated machine to actually do this benchmarking?
Yeah, that is a great question. A lot of folks actually ask that. And isn't, running benchmarks in CI really noisy? And they are. There definitely is noise in CI compared to a wonderful bare metal, isolated, Faraday caged, server that you run all of your benchmarks on all the time. A Docker container-based CI platform where everything is virtualized, right? And you have no control over what else is being run. Can definitely create some noise. And so there are three kind of main ways that you can handle that. The first one is that you could use a bare metal runner. You could set things up. AWS bare metal is pretty cool, and really reduce that noise and use a custom runner. That is going to be quite a bit of engineering, and in the long term, I would love for Bencher to offer that actually as an option. So just make it really easy for you. Again, kind of out of the box, just work and have that available. But currently, we're not there yet, and so you would have to kind of hand roll that yourself. The second option is that you could do something called relative benchmarking, which is each CI run, you actually run your previous branch, your previous commit on your branch, and your most recent commit, and then compare those directly as opposed to all of your historical data. That has the downside of drastically increasing the amount of time that it takes to run in CI. So as opposed to running just once and then looking at the historical data, you're running, say, 6 times, which is 6 times as long. And benchmarks tend to take a while as it is. And so most folks really aren't too keen on that. And then the third option would be to kind of move over from wall clock time to more of an instruction count sort of metric. And so you look at instruction counts and you look at, L1 and L2 cache misses and things like that, and you count those and you use those to kind of approximate the metric that you really might care about, like latency, but it will stay fairly consistent, if not almost exactly the same in your CI environments. And so that lets you kind of get rid of that worry about the virtualization layer there. And then, so there's the 3 options. You can kind of pick and choose between them. But there's also kind of an option that I like, which is just embrace the chaos. Yes, the environment is noisy, and yes, it's not going to catch everything, but it's around 25% variance in there. And so the great thing about having the statistical thresholds in Bencher is you can actually accommodate for that. And so if you have very noisy data because it's running in CI, then the statistics reflect that. And so when you set your thresholds, it uses that information and understands that variance inside of there to, again, not create false positives if, your CI kind of is running a little bit slow. And so that's the cool thing about the statistical thresholds. They aren't simple static thresholds that you have to sit there and kind of nanny to take care of. They're really smart. And so that's kind of my pitch, is to embrace the chaos and just set it up on the system that you have now. And kind of the way I like to frame it is, if you think about it, how much of a performance regression right now can you detect before it reaches production, right? Probably nothing, right? Like, it could be a 2 factors of 10 difference in performance, and you probably wouldn't notice it before it's on fire and affecting your users. And so, even just getting to where you can detect a factor of 2 performance regression or a 50% performance regression is a huge win. And so that's kind of the way that I'm looking at it, is that being able to notice a greater than 25% performance hit is way better off than most folks are right now.
Thanks again for being on the podcast today and showing us Bencher. And Everett, we'll make sure that we put all the links in the show notes and on the website for the SMC Journal podcast.
All right, great. Thank you so much.
So there you have it. What do you think about Bencher? I thought it was very interesting. You can check out the website just like I did. And I'd like to know what you think about this. So you can contact me through various means. I'm on most social networks that are out there. But you can also contact me through regular email at my email address, heyscott@smcjournal.com. And I really look forward to hearing from you. Until the next broadcast of the SMC Journal podcast, this is Scott Moore saying thank you for watching, and bye-bye.